Chapter 4, Section 3, Adding and Subtracting Rational Expressions. So in this section, what we're going to do is we're going to add and subtract basically fractions in algebra. So things to remember is when you add and subtract fractions, you must have a common denominator, and you can only combine like terms. So to add or subtract rational expressions with like denominators, what you're going to do is you're going to combine your numerators where you can, and then you're going to factor, and then you're going to reduce and write your answer in factored form. So here we have a common denominator. The denominator is a group, but it is in common. So since you have your common denominator, what you're going to do is you're going to make this into one fraction. Anytime you get a common denominator, you can make one fraction over that common denominator. So n squared minus 1 you cannot combine, but that is going to be your new numerator, n squared minus 1, over your common denominator of n minus 1. So step number 1 is complete. Step number 1 says to make one fraction, combine your numerators and make one fraction. And then what you're going to do is you're going to factor. So n squared minus 1 is the difference of two squares. So we'll have n plus 1 times n minus 1 over n minus 1. And then the n minus 1s will cancel out, and you get n plus 1 as your answer. This one, same thing. Our denominators are the same, so what we can do is we can make one fraction by combining our numerator. There's no like terms again, so we'll have 6a squared plus 13a plus 5 over that common denominator of 2a plus 1. And now what we need to do is we need to try to factor the numerator. It is a trinomial. Your leading coefficient is not 1, so that would be your bottoms up. So a squared plus 13a plus 30. And I think that will factor into a plus 10 and a plus 3. And then we'll divide the 6 back out and reduce. So we'll have a plus 5/4 and a plus 1/2. And then bottoms up, we'll have 4a plus 5 and 2a plus 1. So there's your new numerator, 4a plus 5 and 2a plus 1 over that common denominator of 2a plus 1, and you can see that those are going to cancel out, and you're going to get 4a plus 5. So what if you don't have a common denominator? Well, the first thing you're going to do is you're going to find a common denominator, and then once you have a common denominator, you're going to rewrite the equivalent fraction, and then you're going to go back to combining the numerators and then factor and reduce. So the first thing we need to do is find a common denominator. The common denominator between 6 and 12 is going to be 12. So in order to make 6 go to 12, I'm going to have to multiply by 2. And since I have to multiply the denominator by 2, I have to multiply the numerator by 2. So that's going to be your distributive property. So we'll have 8x minus 6 over 12 minus, this fraction already has a denominator of 12, so we're just going to leave it alone and have 8x minus 2 over 12. Alright, so we have our common denominator, and now what we're going to do is we're going to combine our numerators by combining like terms, and we're going to make one fraction. So 8x minus 8x, that cancels out. 8x minus 8x goes to 0. And then you have a negative 6 minus a negative 2. Double negatives go to plus, so negative 6 plus 2 is going to be negative 4 over the common denominator of 12. And then, of course, that will reduce to negative 1/3. Now, the variables won't always go away. That's just how this problem ended up, but this won't always happen, so be aware of that. Alright, so what if we throw variables in the denominator? To find the common denominator, what you're going to do is you're going to think, look at your coefficients first, the 12 and the 15. What's the smallest number that both 12 and 15 will go into? And I think that's going to be 60. And then for your variables, it's going to be, if it's a monomial, it's going to be the highest exponent. So it's going to be a squared and it's going to be b. So let's talk about that. For your common denominator, what you're going to do is you're going to find your common denominator for your coefficients, if you have monomials. And then what you're going to do is you're going to write down anything that's already in common, because we are looking at the common denominator. So you already have an a in common, because here this is a times a. So you already have an a in common, this one and this one. But then you need another a for the fraction on the left. So your common denominator for your a is going to be your a squared. And then here we have a b, but this one needs a b, so that b is going to be part of your common denominator as well. So your common denominator is going to be 60 a squared b. So in order to turn 12ab into that common denominator, I'm going to have to multiply by 5, and I need another a. I already have the b, so I don't need to multiply by b. I already have one a, so I need another one. So if I multiply the bottom one by 5a, I'm going to have to multiply the top by 5a. So I'm going to get 35a over 60a squared b minus the problem on the right, this one. In order to get 15a squared to go to 60a squared b, I'm going to have to multiply by 4b, top and bottom. So we're going to have 44b over 60a squared b. Now that I have a common denominator, I'm going to combine your numerators, but there's not any like terms, so we're just going to write them in descending order. So we'll have 35a minus 44b over the common denominator of 60a squared b. Now, something that I want to draw your attention to here is, clean that up a little bit, is if you have a group on top and a monomial on bottom, the only way that you can cancel things out is if you have two groups that are exactly the same. For example, some people will want to cancel the a with the a squared and the b with the b, and you cannot do that because this is a group. And as far as your coefficients are concerned, I can't reduce the 35 with the 60, and I can't reduce the 44 with the 60 unless I can reduce all three numbers by the exact same number, and I can't. I can reduce 35 and 60 by 5, or I can reduce 44 by 60 by 2, or even 4, but I can't reduce all of them by the exact same number, so I can't reduce this problem. This is your answer. Alright, on the bottom, let's try the common denominator again. Between 12 and 8, the smallest number that both 12 and 8 will go into is 24. And then remember, I need an x, because I see one here, and I need a y, because I see one here. So that's going to be your common denominator. So to make 12x go to 24xy, I'm going to multiply by 2y on top and bottom. So I'm going to get 10y over 24xy minus, here to get 8y to go to 24xy, I need to multiply by 3x. So I'm going to get 27x over 24xy. Alright, from here I'm going to make one fraction over that common denominator by combining my numerators, but they're not like terms, so we're just going to write them down. So we have 10y minus 27x. And there's nothing that will reduce because these numbers will not reduce by the same number, so that is going to be your answer. Let's try this one more time with monomials, and then we're going to go into anything higher than a monomial. So here, 7, 4, and 14. What is the smallest number that all of those will go into? And I think it's going to be 28. And then for the t's, I have one here, but I have two here, and I have one here. So they already have one in common, but I need another one to make up for this one. So it is going to be t squared. Alright, so for the first fraction, in order to get 28t squared, I need to multiply by 4t, top and bottom. The one in the middle, to make 4 go to 28, I'm going to multiply by 7. I already have t squared, so I don't have to multiply by the variable. So that's going to be 21. And then that last fraction, to make 14t go to 28t, I need to multiply by, or t squared, I need to multiply by 2t, top and bottom. Alright, so on top we'll have 2, t times 1 is 2t, and then on bottom we'll have that 28t squared. So now that we have a common denominator, I need to combine my numerators, the like terms, so we'll have 20t plus 2t is going to be 22t plus 21 over 28t squared. And again, all three of these will not reduce by the same number, so I can't reduce these. I can't reduce the t and the t squared because this is a group, so that's going to be your answer. Okay, so let's go here. When you have groups, you have to get into a mindset of you have to have like groups in order for them to be in common. So to write the common denominator, you've got to use everything. So let's go back up here and look. The 7, the 4, and the 14 to make the common denominator of 28. That's what we found the smallest number that all those would go into. But notice t squared was our common denominator for our variables, and the reason being is because you have to use everything once and only once. Well, they already have a t in common, so that's why you had 1t. But then we needed another t to make up for this one, so that's why it's t squared. So look down here, we have to use every group once and only once. So we need the x minus 1 group, and I need the 2x minus 3 group. So that's going to be your common denominator. You have to use every group, everything, once and only once. So my common denominator is these two multiplied together, but we're not actually going to multiply them out because we just have to turn around and factor them. But in order to get this x minus 1 to look like the common denominator, I need to multiply by the group of 2x minus 3. And so I'm going to do that on top and bottom. So on top, I'm actually going to distribute because remember your next step is to combine like terms, so I don't need any parentheses. So on the top, we'll get 10x minus 15. But on bottom, we're going to leave it alone so that we don't have to refactor. Alright, the problem on the right, I need to multiply top and bottom by what's missing, which is the x minus 1, in order to make it look like the common denominator. So on top, we're going to go ahead and distribute so that we can combine in a minute. And on bottom, we're just going to leave it as x minus 1 and 2x minus 3. Alright, so now that we have a common denominator, we need to make one fraction. Combine your like terms. 10x minus 3x is going to be 7x. And negative 15 minus a negative 3, that turns into negative 15 plus 3, is going to be a negative 12. And then your common denominator. From here, you would factor the numerator if possible. This is not factorable. And then reduce. So this is going to be your answer since nothing will factor. Okay, let's try again. Here, we need to make this whole number into a fraction of 1. So your common denominator, we have to use everything one time. So our common denominator is going to be that x plus 4 grouping. So the fraction on the left is not going to change. It's already got the common denominator of x plus 4. But the one on the right, I need to multiply this 1 times x plus 4 and this 2 times x plus 4. So 2 times x is going to be 2x, and 2 times 4 is going to be 8, and we're going to put it over that common denominator of x plus 4. Now that we have a common denominator, I need to combine the numerators. So 7x minus 2x is going to be 5x. And then this minus sign, remember, goes to both of these. So it's going to be a negative 8 over x plus 4. Nothing will factor, nothing will reduce. That is your answer. Alright, this problem, I want you to notice something. If you will, notice that you have an a minus 9 and a 9 minus a. So these are backwards to each other. And what I'm going to do is I'm going to show you how to fix this, and then I'm going to show you the shortcut. So if you have something written not in descending order, such as this denominator, let's write it in descending order. So we have a negative a plus 9. And you notice that it's almost like this one, except there's just a negative, or the signs are different. To fix that, we're going to factor out a negative 1. And then what I'm going to do is I'm going to take this negative 1 and I'm going to multiply it times this negative, because this is understood to be, or could be understood to be, a negative 1 there as well. So now what happens is I get 10 over a minus 9. Negative times negative, look, negative times negative is positive. 5 over this a minus 9. And that's how you're going to get a common denominator for these. Combine your numerators and you're going to get 15 over a minus 9. So again, if it's backwards, if they're just different by a sign, what you're going to do is you're going to factor out a negative, multiply that middle sign by that negative. For example, if this had been plus and we multiplied it by the negative, that would become a negative. But since we have two negatives, multiply them together and you're going to get a positive. Alright, so I want you to try these numbers on page 200 and 202. This is difficult, so it will take some practice. Finding that common denominator is probably going to be a very difficult thing, so make sure you practice these. And if you have any questions, just bring them into class and I'll be more than happy to answer them.